Okay, so what do you got?
Can you go chapter 7.5, number 6?
Okay. Oh, well, these problems.
Yeah, they're not.
Okay, number 6, you said?
Yeah.
Yeah.
So I got the recursion equation, but I don't know how to continue on from that. Like, how do I get the series solution essentially?
Right, okay, so. Actually, I had, which has been a while so I recently worked these problems out again. I don't wanna like give away my solution on the screen, so.
It's okay.
And, okay, where did I roll that? Okay, so, and here it just says, okay, just finding two solutions, test for convergence, okay. All right, so you considered, this is for two solutions, two different values um, of S.
Yeah, 0 and 1, right?
Oh, that's strange. I did get it. I do have S equals 0. But the other one involved C, the coefficient C in the equation. Okay, so for the lowest degree term, what do you have there?
Lowest degree, is it just like,
Like when you substitute the derivatives in, and write everything else, like to arrive at the initial equation.
I think I just got S plus J minus 2. Is that like, is that the lowest degree, or is that?
Oh, okay. But then, okay, so that's what you have for your second derivative. But then the second derivative is multiplied by x.
Yes, I get canceled. So like S plus J minus 1. That's the lowest.
Yes. So then, so the lowest possible powers of x come about when you consider a case of j equals 0 in each sum. And you're going to get something from the, so one of the terms that you'll get that has that lowest degree is coming from a first derivative term. Now, in the s equals 0 case, so you got like a reasonable like recurrence relation. Like to describe like aj plus 1. Okay. What sort of form I have in mind for this solution? I mean, there's number coefficient a in here. I imagine you did like kind of like in the examples where you write out like
J is 0 and then
the first few, yeah. Okay. Yeah, so you're gonna get some.
Wait, so you're in the sole equations where S equals 0 and then S equals C, you said?
Well, not S equals C, but it
oh, like
involves,
yeah, C equals 0 or something, or like
yeah.
So how
Yeah,
did you find the in the SOA equation? Do you, was it whenever you were, like moving the summations around?
okay, so what happens is, so since you know you're gonna have two terms that you separate from the rest, being second order equation, for each summation, when you, consider the starting values of j in that sum, then you can see like what is the lowest possible power of x that you have in the equation, and then the second lowest power. And so when you supposed to identify those two powers, when you gather all of those terms and write them separately, and then whatever's left is possible to unify into one summation for everything else. And what happens in this case is that lowest degree, so for second derivative, you have x to be f plus j minus 2, but then you have it multiplied by x, so then you have f plus j minus 1. First derivative, you have s plus j minus 1 times c minus x. So the part where you're multiplying by c will also give you x to the f plus j minus 1.
Yeah.
The final term will have x to the f plus j, so that'll be higher degree. So the second and first derivative terms both contribute. As far as what I'll be satisfied with for an answer, I would be fine with what's actually shown as an answer for a couple of the other problems where you're just working out the first few. Like, sometimes it's pretty onerous to go with a nice formula that encapsulates everything. Like, it may be possible to express certain things using factorial-like notation. Like, you're going to get expressions in this case, for example, where you have something like, since a is one of the coefficients in the original equation, products involving like a minus something. And I believe there is a way to express that using like some sort of generalized binomial coefficient, but I mean that's not something I covered. So like if you wanted to do like as a dot 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 or something like that, that'll be fine too.
Okay, and for the third term in question 6, it's like a times y.
Yeah.
Would aj times a have any special interaction, or would it just be like factored?
Oh, it was 8.
Like for the last term, it's like aj times like s plus j minus a. Can you kind of combine two of those?
Oh, okay. Yes. So yes, you're gonna have a times aj. Okay.
I wasn't sure if it was like a times like aj plus 1 or something, because you multiply by a, but.
Oh, yeah. A is an unfortunate choice of constant name.
Okay, it was just constant, all right.
Yeah. Yeah, so it's independent of the.
That's what I thought, right, so that it wasn't sure.
Yeah. But yeah, so I was looking at the notes, it's like, wow. Okay. And you said that was your only question left?
Yeah, well, I had like one for number 2, but I was kind of, it was more like, I wanted to ask you could see my work, and then like.
Oh, I see,
Yeah.
Right. Okay. I don't think there was any preemptive hints I should be given about that one. Well, okay. Actually, I don't know if I mentioned this before or if I meant to. For 752, use a power series that is centered at x naught. Because for examples we've had, we use a power series that's centered at 0. But it's more convenient in this case to talk about x naught specifically being an ordinary point, the center there. Okay, the problem tells you to do that. Okay. And the reason for the assumption of, oh, okay. Use it for a solution and for the coefficients in the, in the ODE. So they have, like a Taylor series expansion as well. And because those coefficients will be defined at x naught, you can just go ahead and expand those around x naught. So then you're going to have, so what happens is, for example, p of x times y prime, you're now looking at a, work with a product of power series. And this get an idea of how it works. I'll just make an example involving center of zero. If I have f as a sum over j, and then I'll have another function g of x. I'll use a different index here. So then you have f times g. Then you have the double sum j plus k. So then what you can do is make a change of variable, the index variable. Let n equal j plus k. So what that means is you can use that to eliminate, express one of these indices in terms of n. So I'll have, I have something like this. So now I'll have some j's and the sum over n. So now x to j plus k now be x to the n. And then where I had k before, I'm going to have n minus j. So now each coefficient in the, so this is a degree n coefficient in the power series of a product. And it comes from combining, kind of like a convolution in a way, of coefficients of f and g. Now, in the simplest case, say, like if I let these be conventional power series, which you would also do in the problem, where your indices start at 0. Okay. So then if I want to write some of my product, is in this form, where the coefficients are given by this. So then the lowest degree cases can be worked out. So you have like A0 would just be F0 G0. A1 would be equal to F1 G0 plus F0 G1. Like all possible combinations of indices that sum to the index here. So then that way you can get a handle on what the integral equation is, even though it's a very big abstract case, and see what you get.
So we're to do that for number 2, or?
Yes. And thankfully, these are the only cases you really need. Or you see what you get when you take the derivatives and all that. Okay, so x really gonna have 3 power series in all, one for Y, one for P, and one for Q. Okay, Dale, do you have questions?
It's not a very good question, but it's something I can't get over, and I can't find this result anywhere.
Oh, okay.
All the way back in 614.
Oh, wait, 614?
Yes, sir.
Wait,
No.
okay.
514.
Yeah, I was gonna say, we never touched chapter 6.
Well, maybe that's why I'm so far behind. I'm doing chapter 6 instead of chapter 5.
Oh,
No, I am doing chapter 5. Okay, so here we go. I
I
get the result that we want to get. I get that C sub n is equal to A sub n
okay,
to minimize the mean square error.
yeah.
But the only way I get that result is if the integral from a to b of w of x dx is equal to 1.
Oh,
I can't justify that. I can't find that anywhere. And I feel stupid because I feel like it's going to be either something that's obviously wrong or obviously right.
okay. Let's see. All right. So, is it convenient for you to show what you have? I know you feel like you tend to type your homework.
You just want me to share?
Yeah. Okay. If I go ahead, I don't know if you're able to. If I unshare.
Yeah.
Okay. Let's. I don't know if it'll be possible, but. Oh.
Is it coming through?
Yeah, it is. Okay. Yeah, because maybe there's just spot something here and. Okay. So. All right, so here you got inner product of K, and then you have N. Okay, okay, what happened was, I'm like, okay, okay, I'm looking at the line where you have, yeah, okay, the longest line that you have, where it's the integral of -2, blah, blah, blah.
Mm-hmm.
Yeah, that right there. Okay, now the integral, the second integral, so that amounts to, if you consider that the 2 and the Cn are constants, so you pull them out of the integral, and you're left with the, okay, so what's left is the integral from a to b of phi n, phi k, w of x dx. And so the problem is, okay, you have like the phi n are orthonormal, but then you have to think about what that means. The scalar product in this case is, I guess, the scalar product of f and g. Okay, you know what? As I see what I need to see, so now go ahead and unshare, and I'll return to my notes. Okay. Okay. This is. Whoops. All right. So the scalar product that's being used for this problem is, okay, so we have f g is integral from g of w of x dx. Okay, so, and that, so you know that when you have an orthonormal set, so if you take one of these functions, like phi n, then scalar product of phi n with itself will be equal to 1. So, yeah, so the idea is, yeah, you actually wanted this integral to be 1, and it is 1, but the thing is, you deleted the phi n from it. Because, so, taking into account that the phi n are orthonormal means that this integral, with the appropriate f and g filled in, is equal to 1.
Gotcha. Okay, the phi are orthonormal with respect to this weighted inner product,
Yes.
which is why the W should have gone away before. Okay.
Yeah.
Thank you so much.
Okay. So we assuming it's 1 with respect to a conventional integral, or like no a function? It sounds like that's what's happening. Something like
Effectively,
that.
what I did was I was focusing on inside the summation
Okay.
and thinking too naively about that the phi sub n times phi sub k would be the product of the two phis would be equal to 1.
Yeah, because all of a sudden they went away. So yeah.
Yeah.
Okay. All right.
Thank you.
Yep. Okay. Well, you two are the only two here. Either of you have anything more?
I don't have any more questions. Thank you for doing this.
Yep. Well, I guess well said then, and I guess anybody else will have something to watch. So. Okay. Well, 22 minutes or so.